As he said, it occurred to me a few weeks ago that a lot of the people coming here don't remember the Apollo flights because you weren't born yet. And looking at the audience, I would say about 90%. How many of you raise your hands if you actually saw the Apollo program live? These are people who know how to sit in the front row. Look at that. Thank you very much for coming. This will all be review for you. You'll ace the test at the end, no problem. The rest of you, pay very close attention. So, for those who have other programs and things to see, we'll start with the basics. The Apollo program sent a man to the moon. You knew that. From 1969 to 1972, 12 Americans walked on the moon, but 24 Americans went to the moon. So why is there this disconnect? Why did only half of them get to walk on the moon? Well, the other half actually just circled the moon, some of them by intention, some of them by accident. You might recall Apollo 13, where they had an emergency on their way to the moon. 2 of those guys were going to walk on the moon, but they were lucky to get back with their lives. Neil Armstrong was the first person to walk on the moon, and Gene Cernan was the last. Oh no, we hope not. Gene Cernan was only the most recent. There will be other footprints on the moon. In the past 47 years, no humans have gone farther than 353 miles into space. Now, if you've been paying attention in your science classes, you know that the moon is 250,000 miles away, 250,000 give or take. So in the past 47 years, we've only gone 0.0014 of the distance to the moon. That's roughly the distance from here to Santa Fe, New Mexico. Do we need to go back? Darn right we do. So the first big question is, why? Why would anybody want to go to the moon? It's far away, it's dangerous, it's expensive. Why did we go to the moon? And the short answer is because of the Cold War. I believe that most of the people in the audience actually were born after the end of the Cold War. But there was this thing called the Cold War. The United States and the Soviet Union were the key players. They had thousands of nuclear weapons. We had thousands of nuclear weapons. If a nuclear war had broken out, it could have ended civilization and wiped out most of the human race. It might have wiped out most of the species on the planet. Neither side wanted that to happen, but we were very worried about a sneak attack from the other side. They were worried about us attacking them. We were worried about them attacking us. So we developed the idea of mutually assured destruction. That means that they knew that if they attacked us first, enough of our missiles would survive to nuke their country back to the Stone Age. And we knew that about them. So it turned out that we didn't have a nuclear war. We did have a couple of smaller practice wars where it was a hot war. Korea and Vietnam come immediately to mind. But why would those threats be a reason to send people to the moon? Well, we were in a competition with the Soviet Union for supremacy in technology as well as military hardware. And the Russians were beating us. They did something in 1957 that shocked America and scared us to death. They put a satellite up. It wasn't much of a satellite. It was called Sputnik 1. It was a silvery ball about this big with 4 big antennas on it. And it didn't do much. All it had in it was a radio transmitter and some batteries. And it just kind of went beep, beep, beep. But every American could go out on a starry night and look up and see this thing flying over. And if they could do that with a little radio transmitter, could they do that with nuclear weapons? We were shocked and scared, and we wanted to develop something equally important and technologically advanced. Well, the Sputnik project was part of a scientific push by all the countries on Earth for the International Geophysical Year of 1958. And we had plans to put up a satellite, and here's what the Russians did before we could launch our satellite. Less than a month after they put Sputnik 1 up, they put Sputnik 2 in orbit, and that had a dog in it. So they had developed life support systems. They could put living things in space. And then December 6, 1957, we were ready for our first satellite launch. And this is how it looked when it took off. If you thought we were embarrassed before, the whole country was humiliated. This was broadcast live on national TV. It was a shock to our core. The Russians could not only succeed in their space program 2, 3, 4 times, but we couldn't even seem to do the first step correctly. About 80 days after the first failure of Vanguard, we did put up our first successful satellite. It was called Explorer 1. It was launched on January 31st, 1958, and it went into orbit. These are the guys that were involved in putting it up. From left to right, they are Mr. Pickering, who was the head of the project and directed the technical people who put it together. The guy in the middle is James Van Allen. He's the scientist who had predicted the existence of radiation belts surrounding the Earth. But the Explorer satellite actually proved that they were there, because this wasn't just a satellite with a radio transmitter. This had scientific instruments on board, and they discovered that the Van Allen radiation belts were real. The third guy on the right was Wernher von Braun, and we'll talk more about him later. The Russians were still ahead of us, though. In September of 1959, they launched Luna 2, and it hit the moon. This was an extremely important technological achievement because the moon is 250,000 miles away. And then shortly after that, they launched Luna 3, which went around the moon and took the first pictures ever of the far side of the moon. They weren't very good pictures. They were showing something that had never been seen by human eyes before. No one had ever seen the far side of the moon. And then in April of 1961, they killed it again. They put a person into orbit around the Earth. Yuri Gagarin became the first human being to actually travel in space. We followed up about a month later by putting Alan Shepard into space, but it wasn't really an orbital flight. It was suborbital, about what happens when you take a ball and throw it into the air, and it goes up and it slows down, and then it stops, and then it comes back down. And that's what happened with Alan Shepard's first flight. It was a total of 15 minutes of space flight, and our rocket was reliable. But nevertheless, President Kennedy went before Congress, and this isn't a picture of him addressing Congress. I didn't have a picture of that. But he addressed Congress and he said, I think this nation should set itself the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth. That was about 8 years away, and we didn't have the technology to do it. Our entire spaceflight experience at that point was 15 minutes of Alan Shepard's suborbital flight. We had no drawings or blueprints for any lunar hardware. 1 out of 3 of our rocket boosters exploded before they got into space. And yet he was setting this impossible goal, completely impossible goal, and somehow America bought into it. A better speech, in my opinion, is the one that he gave a few months later at Rice University in Texas. It was a hot day, about as hot as it is here today, in a football stadium, and he gave a speech that's about this long. You can Google it. It is wonderful. And in that speech is a paragraph that I'd like to quote. But why, some say, the moon? Why choose this as our goal? And they might well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon in this decade and do the other things not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one we are willing to accept, one we are unwilling to postpone, and one which we intend to win. It was stirring, it was goosebump-ing, and people got behind it. We'll talk about the spacecraft a little bit. This shows to scale the 3 steps that we took to the moon. The first step was the tiny little one-person Mercury spacecraft. It was basically just proving that America could launch an orbital spacecraft and have the occupants survive. We'd have enough life support, we'd have protection from cosmic rays. The longest mission lasted about a day, and it proved that we could get people into space and get them back again. The second step was the Gemini spacecraft, which carried 2 astronauts, and it proved most of the technologies that we would need to make a lunar trip. Technologies like long-duration spaceflight, up to 2 weeks in orbit. Things like generating our own electricity and water with fuel cells, rendezvous in space and docking of 2 spacecraft together. The spacesuit technology that we would need if we were going to leave a spacecraft and walk on the moon, that was proven by taking spacewalks from Gemini spacecraft. And then at the top is the Apollo spacecraft, the command and service module, and the lunar module. But what I really like to point out is look at the different sizes of the boosters. At the bottom here in outline is the Mercury Atlas on the right that was able to put 1 person into orbit. To put 2 people into orbit, you need a little bit bigger rocket, and those Titan II boosters were made right out here in Littleton. But look at the difference in size of the rocket that took men to the moon. It's huge. It's enormous by comparison. The Saturn V rocket was 363 feet tall. That's as tall as a 36-story building. And because we don't have a 36-story building for you to compare it to, I took a picture of the state capitol dome and put it to the same scale. This rocket is about 100 feet taller than our state capitol. That's how tall it was. It weighed 6.5 million pounds. Now I'm going to ask these kids in the back rows, what is the biggest animal on Earth? Just yell it out. The blue whale. You guys nailed it right off the bat. The blue whale is indeed large. See the diver on the left side of the picture there? Well, it would take 45 blue whales to equal the weight of the Saturn V moon rocket. Think of that. So to put something like that into space, it's going to take a lot of thrust. Now these are the basic portions of the Apollo moon rocket. The first stage, let's talk about that a little bit, because that was what did the literally heavy lifting of 6.5 million pounds. It's big. You can see the little guys in the green vests at the bottom there. Look at the size of those rocket engines. 12 feet 4 inches across at the base of each of those rocket nozzles. You can get a better picture of how big it was over there in the exhibit because we've painted circles on the floor. The big blue circle represents the diameter of the rocket body itself, and the 5 gray circles represent the size of the rocket nozzles. Here it is in the vehicle assembly building. There's some people down at the bottom there too. At launch, it generated 7.61 million pounds of thrust. You've got to have more thrust than weight if the thing's going to move, right? So all of that thrust, I can't get my head around 1 million, can you? And thrust is energy. How can we, I tried several different ways of creating analogies that would tell us how much actual energy that was. The one that I ended up with was, are any of you familiar with the power plant that puts electricity out for the whole city of Denver? This is a city of 2.5 million people in the metro area, and the Cherokee power plant generates the bulk of that electricity. It would take 240 of those power plants running full tilt in order to equal the power that was generated by the Saturn V during its launch. There's the Rocketdyne F1 engine. There were 5 of those at the base of this rocket. That's how big it is. They were thirsty. They drank 671.4 gallons per second. You thought your parents' SUV got bad gas mileage. Per engine, so multiply that by 5. These 5 engines, the pumps that fed the engines could empty an Olympic-sized swimming pool in less than 3 minutes. And the teachers always want me to show my work, so there it is. So this guy standing beside the rocket is Wernher von Braun again. I said we were going to talk about him a little bit more. He was a key player in designing this rocket. He started out when he was a teenager in Germany working in a model rocket club. It was fun. And then the Nazis came to power in the 1930s, and by then the kids in the rocket club were almost grown up, and the Nazis said, hey, we could use your expertise in our artillery area. So they pretty much drafted the whole rocket crew into their artillery and weapons division and gave them enormous budgets and said, design some rockets. And Wernher von Braun and hundreds of other scientists came up with the most advanced rockets on the planet. Now, they wanted to go into space and carry people into space and go to other planets, but the Nazis wanted to put bombs on these and launch them against other countries. There's still a lot of contention about whether Wernher von Braun was a dyed-in-the-wool bad guy Nazi, or whether he was just paid by the Nazis and obliged to be a member of the Nazi Party in order to keep his job and his skin. But this is the V2 rocket that he and his team designed, most advanced rocket on the planet. And it was able to hurl a ton of explosives several hundred miles. It was the first ballistic missile. They launched thousands of these against England and different places in Europe, the Netherlands. And then at the end of World War II, the United States had the foresight to go over there and collect as many of these Nazi rocket scientists as we could and bring them back to our country to work for us. And they did marvelous work. They were the ones who designed the booster rocket that put Alan Shepard into space in 1961. And then they thought really big, and they came up with the Saturn V moon rocket. So we'll talk a little bit about the second stage. It was very much like the first stage, except that it didn't need to be as big or as powerful because it wasn't lifting as much. All the propellants and engine weight of the first stage would be thrown away, and then it only had to lift the second and third stages and the spacecraft themselves. That stage also had 5 engines. They burned, instead of kerosene and liquid oxygen like the first stage, they burned liquid hydrogen and liquid oxygen. And it puts out an exhaust that is called dihydrogen monoxide. It's terrible toxic stuff. 2 hydrogen atoms and 1 oxygen atom. Wait, oh, we're not there yet. The exhaust was H2O. Anybody know that chemical formula? Everybody, great. You can drink the exhaust. It was basically steam. It was water. And so was the third stage. It burned the same propellants. It had 1 of the engines that the second stage had 5 of. So let's look a little more closely at the third stage and the Apollo spacecraft. This third stage was called the S4 stage. Why did they call the third stage S4? You can Google it. This is just the basics. The lunar module was nestled with its landing gear folded up on top of that stage, and then above that was the service module that had all the propellants that the astronauts would need to come back from the moon, as well as their breathing oxygen and the fuel cells that would make their power while they were going to and from the moon. This is what it would have looked like if you could have seen it in space, in orbit around the Earth. But there weren't any cameras up there, so we don't have a picture. This is an artist conception. So the one piece that I haven't talked about is the escape tower at the very top. The launch escape system was only designed to be used in an emergency. If something had gone catastrophically wrong in the first couple of minutes of the space flight, the rockets in that escape tower would have fired and pulled just the command module with the 3 astronauts away, and the parachutes would have deployed, and they would have landed safely in the ocean off the coast of Florida. This is what the command and service modules look like in space. This is what the lunar module looks like when it's still nestled in the top of the S4B stage. This is what the inside of the command module looked like. Now I can see some of your eyes getting big. You're saying, holy cow, how did the astronauts manage to handle such a complex instrument panel like that? But think about this. If you go home and you count every light switch, all the buttons and knobs on your stove and your refrigerator and your microwave, all of your remote controls, all of the buttons on your video games and so forth, and you add all those up, it's probably about that many. They're just collected into one place. And it was very easy for the astronauts to remember because this group is about ventilation and heating and cooling. This group over here is about navigation. This group down here is about the health of the service module. So once you know your way around that panel, it's very easy. The lunar module had two parts, and its job was basically to go down and land astronauts on the moon. It took 2 astronauts down. It didn't even have seats. The astronauts stood up inside the lunar module the whole way down to the moon, the whole way back, and for most of the time that they were crawling around on the surface. It lands on the moon. It has 2 major parts, the descent stage, which is colored yellow and gray in this picture, and the ascent stage, which is the upper part that goes back up into space and brings the astronauts back to the command module. This is what it looks like separated, with some cutaways there so you can see some of the internal parts. And this is what it looks like in real life. This is the lunar module Eagle. Like all good pilots, after they separated from the command module, they wanted somebody to do a little pre-flight walk around. So they sat outside the window of the command module and had Mike Collins, who had stayed inside the command module, look it over as they turned it very slowly around, looking for anything that was hanging loose or might be torn or broken. This is the lunar module on the moon. And this is the ascent stage as it's coming back up to dock with the command module. Let's talk for a minute about these guys who went to the moon. Astronauts, first of all, their main trait was they were crazy smart. By smart, I mean that all of them had college degrees. Now, this was in an era when not everybody went to college, and a college degree was still a pretty special thing. But not only that, almost all of them had master's degrees. That's after you get a college degree and you go back to school for a couple more years and study something very carefully in depth. 3 or 4 of them had doctorate degrees, PhDs. So what kinds of things did they study? Well, as you might expect, mostly to do with aeronautics and space flight. Aeronautical and aerospace engineering, mechanical engineering, electrical engineering, nuclear engineering, aeromechanics, things like that. But a lot of them were also drawn to heavy-duty science and studied chemistry, physics, and geology. Indeed, if you were here and saw Dr. Harrison Schmitt present a couple of nights ago, he was chosen to be an Apollo astronaut primarily because of his geology background. Some of them had kind of off-the-beaten-path degrees, which they got later in life, industrial management and Masters of Business Administration. Almost all of them were pilots. Initially, to be an astronaut, you had to be an experimental test pilot. And then as they broadened their horizons and started accepting other people, then fighter pilots and other pilots were included. The majority of them built model airplanes in their youth. That is a key factor there, because when you build models, not only do you learn about aircraft and aerodynamics and so forth, but you're also building the skills that you'll use if you choose to go on and become an engineer or a scientist or an astronaut. You're learning spatial perceptions. You're learning to do things in a sequence, to do procedures correctly. They were also extremely fit. They were not athletes in the sense that a heavyweight boxer or a football player or a basketball player would be, but they were very physically fit. And how do we know that they were very physically fit? Because doctors poked and prodded and examined them every way you can imagine. So these were the most carefully documented human specimens on the whole planet. They had courage. They had already proven courage by flying combat missions in Korea, some of them even in World War II. And as I said, a lot of them were experimental test pilots, where you're continuously having to deal with unknown situations, being cool under pressure, and dealing with emergencies and deciding whether you can bring the airplane back or it's time to get out. One of the examples that demonstrates this most wonderfully is this one. This vehicle is called the Lunar Landing Research Vehicle. It was basically a big jet engine pointed straight down that would cancel out 5/6 of the Earth's gravity, leaving the pilot with just 1/6 gravity like he would find on the moon. And it was controlled by rocket thrusters similar to the lunar module. So this would give the astronaut practice in managing a lunar module descending to the lunar surface. Well, it was a finicky machine, it was difficult to fly, and it had a lot of mechanical bugs in it because it was an experiment. And one day Neil Armstrong was flying it, and there was a mechanical problem, and it went out of control. Well, he knew that this was one of those times when you have to leave the aircraft. So this is Neil Armstrong ejecting, that's the flame near the top, and that's the engine disintegrating on the bottom. Neil Armstrong ejected, his parachute opened, the lunar research vehicle crashed in a big ball of flame. Neil Armstrong guided his parachute away from the flames and landed. And if you were here to hear Dr. Schmidt speak 2 nights ago, he said one day he was walking through the hallways of NASA where the astronaut offices were, and he said, "Neil, I heard that the Lunar Landing Research Vehicle just crashed." And Neil was doing paperwork at his desk, and he said, "Yep, that was me." That's cool. These guys were also tough. They had to be, because they didn't know in those early days where they might come down on Earth. Re-entry technology was not too well defined then. They couldn't guarantee that there wouldn't be a problem where they'd have to re-enter somewhere other than their landing area. So they got training in how to survive in jungles, how to survive in the desert, how to survive on the ocean in a life raft, how to survive in polar areas until they could be searched and found. This is the original 7 Mercury astronauts undergoing some desert survival training. The way this training worked, the Air Force would load these guys into a helicopter, fly them to some uninhabitable place, and drop them off with exactly the kinds of things that they would have if they had just re-entered from space. A parachute, a survival kit, and very little else. So these guys have just completed some desert survival training. They've had to eat bugs and lizards and plants. They've had to make their own clothing to ward off the desert heat because your spacesuit isn't going to do that very well. So they've made from their parachutes Arab-style burnouses, which is what the Arabs have been keeping cool with for hundreds of years. And they don't look very happy. They look tough. In addition to that, they had to be tough to survive the NASA training to be an astronaut. This machine is a centrifuge. You put human beings inside that ball that's off to the right there, and it spins around in a big circular room and generates more and more and more gravity. 6 Gs, 9 Gs, 12 Gs, 20 Gs, and you're plastered like peanut butter smeared across the outside of this thing. The astronauts had to do this not out of sadism on the part of the people that were testing them, but because when you take off in a rocket, you're exposed to that level of G-forces. Usually not 15 or 20, but at least 6 or 7, and for several minutes at a time. And during an emergency, you might be subjected to 12. They also had to do all that egress training and water survival training. They were also, in addition to being tough and smart and fit and all that, articulate. These were America's spokespeople. These were our ambassadors to the rest of the world. So they didn't want some guy who would suddenly make an awkward comment or use profanity or swear in front of a TV camera. So these guys were just as good in front of the public as they were in the cockpit of a fighter plane. They could go into a school, they could talk to little kids, they could talk to presidents, they could talk to foreign heads of state, and they wouldn't embarrass NASA or the United States. And they were the rock stars of the 1960s. Forget Cardi B and the Kardashians. These guys had what it took. They were on the covers of magazines. They were the subjects of TV documentaries. They were on the radio. They were in parades. They were idolized and worshipped. There were G.I. Joe astronaut figures. There were Barbie astronaut figures. There were model kits. They were on the covers of all the magazines. They were everywhere. TV series used to feature pretend astronauts in their starring roles. Does anybody remember I Dream of Jeannie or Lost in Space, things like that, The Outer Limits? Astronauts were the people that you wanted to be, and if you were a boy growing up in the 60s, you probably wanted to be an astronaut or at least a pilot. I know I did. And if you did something like going to the moon, then you got a ticker tape parade in New York. They also got other perks. Astronauts were known for their risk-taking behavior. They drove fast cars, and most of them got Chevrolet Corvettes. And they later had a deal. One of the car dealers in Cocoa Beach, Florida, said, you know what? I bet if we give the astronauts cars to drive, that we'll get a lot of good publicity out of it and sell more cars. So he leased brand new Corvettes to the astronauts for $1 a year. And at the end of that year, they could trade in that car and lease the next Corvette for another $1 for the next year. And it was a sweet deal for the dealer because he got back these cars that had been driven by the most famous people in the world. And he could sell those for more than they could sell a new car for. But the astronauts were very quick to point out that it wasn't them who did all the work. They always said that they were just the tip of the sphere. They were the part that people could see, but they couldn't do it without the support of hundreds of thousands of people that were designing the spacecraft, sewing the spacesuits, doing the calculations, and that sort of thing. Now, naturally, you immediately think of engineers when you think of that, but there were lots and lots of professions. Now, for these younger people, if you're thinking that you really want to be part of the space program, but you don't really want to ride the centrifuge or the Vomit Comet, and you really don't care to go into space, there are dozens and dozens of other careers that you can pursue that will be just as important to getting people to Mars and beyond. Some of those might include just being a construction worker. The guy in the hard hat is the contractor that managed the construction of the launch pad that all the moon missions were launched from. The suit technicians and the clean room technicians who helped the astronauts into their spacesuits made sure that the spacecraft wasn't contaminated by dust and dirt. The machinists who built the high precision parts that went into all those engines, and rows of engineers working at drafting tables. In those days, there were no CAD design programs. Every engineer drew things on paper with pencils and pens. Did they allow girls to play? Not so much. It was really a hard time for women who wanted to be part of the space program. There were no female astronauts, at least not American ones, until Sally Ride, 20 years after we went to the moon. The women that you see in these pictures were very much breakers of the glass ceiling. They struggled and fought and were better than the men in order to get to where they got. Some of them worked in mission control, some of them did calculations, some of them sewed the spacesuits, and in this picture of mission control on the lower left, you can see the whole mission control room for Apollo 11 moments after the Saturn V lifted off. They've all left their consoles and turned around big windows that face the launch pad, and they're watching that moon rocket soar into the sky. There is one woman in that entire room. To help you spot her, there's an arrow. Her first name is Joanne. Forgive me, but I've forgotten her last name. Let's talk about the mission just briefly. The mission involved lifting off from Florida and going into orbit around the Earth. That used up the first 2 stages of the moon rocket. So now you've just got the 3rd stage left and the Apollo spacecraft. After checking things out, they fired that 4th stage engine, which gave them enough extra speed to get out of Earth's orbit and start heading towards the moon. They boosted the spacecraft speed up to 25,000 miles per hour. So now you're going 25,000 miles an hour away from the Earth, but the Earth still has gravity. It's still pulling you back, slowing you down. So all the way out until they were about 7/8 of the way to the moon, they were slowing down, slowing down, slowing down. From 25,000 miles an hour, they slowed down to about 3,000 miles an hour, about 1/8 of their original speed. And by then, the gravity of the moon was stronger than the gravity of the Earth because they were so close to the moon, and they started falling towards the moon and accelerated faster and faster until they went into orbit around the moon by firing that rocket engine a third time. Whoops, I went too far too fast. Once they were in orbit around the moon, they did their final checks, and 2 of the astronauts got into the lunar module. They detached from the command module and proceeded to descend to the lunar surface. In order to slow from orbital speed to a speed that would just gently touch down on the moon, they had to use the descent engine, and that provided enough braking thrust that they could land and safely get out of the lunar module. They walked around on the moon, they gathered samples, they set out experiments, and then they lifted off in just the ascent module using a completely separate rocket engine, which had to be extremely reliable. And they left the descent module on the moon to act as a launching pad for the ascent module. They flew back up to the command module and rejoined the astronaut that was up in space. From there, they fired that propulsion engine one more time and started their trip back home. It took about 3 days to get to the moon and about 3 days to get back from the moon. So now we'll talk specifically about Apollo 11. It took place 50 years ago this week. Tomorrow is the anniversary of the launch of Apollo 11. These are the 3 guys who did it. You've heard their names, now you're seeing their pictures. Neil Armstrong and Buzz Aldrin in the foreground. Those are the 2 guys who went down in the lunar module and walked on the moon. And Mike Collins, who stayed aloft in orbit in the command module. The mission started literally years before the launch. These guys had to learn a lot of very specialized things that were unique to going to the moon. Here, they're studying geology. It would have been a terrible thing if they had gathered up a bunch of samples and come back to Earth, and the geologists on Earth had looked at them and said, "These are all the same kinds of rocks. Why didn't you get a variety?" So they learned enough geology that when they were on the moon, they could pick out a variety of different samples to bring back. And then they had to learn how to pick up those samples wearing a heavy spacesuit. Now on Earth, that spacesuit and all the gear on its back weighs about 300 pounds. On the moon, with 1/6 of Earth's gravity, it only weighs about 50 pounds, but that's still a lot. Plus, it is pressurized. Imagine those hospital gloves that you blow up and they form the shape of a hand or a turkey if you've got a good imagination. That's essentially what a spacesuit is. It's a form-fitting glove that holds pressure in the shape of a human body, and then it's surrounded by layers and layers and layers of insulation and other things to keep the astronauts safe. Well, once it's pressurized, it likes to stay in the same position, and in order to bend it in any way takes great effort. So even closing your hand, which is so easy to do on Earth, would be like squeezing a tennis ball in the Apollo moonsuit gloves. And they're not very dexterous either. They're very thick and bulky, and they've got little silicone rubber glove tips on them. So they had to learn how to pick things up and how to maneuver around, use a camera, take pictures. Then they had to seal the samples inside containers that would preserve them on the trip back to Earth. You don't want to let the atmosphere from the spacecraft get in there and maybe contaminate your carefully gathered samples, so they had to put them into vacuum-tight boxes and learn where to stow them in the command module so that they'd make it safely back to Earth. They had to learn to take core samples, which is where you drive a hollow tube into the surface so that you can see what's below the surface of the moon. And of course, they had to do all that procedural training in how to get in and out of the spacecraft and operate the spacecraft when they were in space. They used simulators. These were the most sophisticated simulators on the Earth. In the foreground in green is the lunar module simulator, and the tan simulator in the background is for the command module. They could practice for all kinds of normal procedures in there as well as emergency procedures. They practiced every day, all kinds of emergencies, all kinds of contingency plans. They worked out a lot of the problems of how to do things and in what order to do things so that they knew that they would be able to do them correctly in space. Here's Neil Armstrong in the lunar module simulator, you don't just go in there and practice in shirt sleeves. You need to wear a spacesuit so that you know that you can do this when you're coming down on the moon. Meanwhile, the Apollo moon rocket was being prepared in the vehicle assembly building, and then they rolled it on the crawler tractor miles to the launch pad. And then on that wonderful moment when they ignited all the engines and it broke free of the Earth, they were on their way. When you get out about 10,000 miles away from the Earth, for the first time you can see the entire Earth as a complete sphere. Any closer than that, it still has a horizon. It's basically like flying in a very, very, very high altitude jet. There's always some more over the horizon or off to the sides. But when you get out far enough away from the Earth, you can see it as a finite system all on its own. They looked back at the Saturn 4B stage after they took the lunar module out of it. And then they coasted most of the way to the moon and sent back TV broadcasts so that people on Earth would know how things were going. Ate space food, told astronaut jokes, who knows. When they got closer to the moon, they checked out the lunar module. And this is a montage of the landing taken through the window, Buzz Aldrin's window on the lunar module. I couldn't get the video to actually embed, so this is just a series of pictures that shows the shadow of the space probe coming down. You can see dust being blown away by the descent engine there. You can see the shadow of the contact probe and the landing gear leg. And then finally, the shadow pretty much blots out the whole picture. And there was this pregnant silence, and the people in mission control don't know if they've landed or if they've crashed. And finally, Neil Armstrong says, "Houston, Tranquility Base here, the Eagle has landed." And the Capcom, the capsule communicator on the ground, said, "Thanks, Neil. You got a bunch of guys about to turn blue down here. We're breathing again. Thanks a lot." And then a couple of hours later, we were treated to the view of Neil Armstrong coming down the steps. One of his first jobs, when he was squeezing through the narrow hatch and coming out onto the porch of the lunar module, was to jerk on a lanyard that would open up a panel and start this video camera that sent the pictures back from the moon. Now, people often wonder, why is it so shadowy? Well, when they came in to land, they wanted to be able to see the shadow of the lander coming down to gauge their height more accurately, so they landed with the ladder in the shade, and that's where he backed down, so he's in shadow there. Everybody thinks that this is Neil Armstrong's boot print. It's Buzz Aldrin's boot print. Both of the astronauts had an enormously long list of tasks that they were to accomplish in the few short hours that they were on the moon. And one of Buzz Aldrin's tasks was make a boot print, take a picture of it. So it's very similar to Neil Armstrong's boot print. I doubt that either of them could tell the difference, but it's Buzz Aldrin's. This is a picture of Buzz Aldrin on the face of the moon. But if you're perceptive, you can also see Neil Armstrong's picture there too, reflected in the gold helmet visor. They had a lot of work to do. This wasn't a vacation. People had spent a lot of time and money to get them there. They had a lot to do, so they were setting out experiments, they were taking pictures, they were doing chores, and they worked hard for the entire time that they were on the surface of the moon. Here they're taking a lunar core sample. Meanwhile, Mike Collins, he's kicking back reading magazines. No, not really. He's going over procedures. He had his list of tasks to do while he was in orbit, waiting for those guys to come back. He had to take pictures of the moon, especially of the far side. He had to scout out future landing sites for future Apollo missions. So he was a busy guy. Here he's actually going over some checklists. So finally, the ascent module blasts off from the lunar surface and comes up and rendezvous with the command module, and just as they're approaching, there's an Earthrise in the background. How cool is that? And then they coast all the way back to the Earth. I should mention that firing the SPS engine on the back of the service module, the most critical time when it really, really had to work was when they were on the far side of the moon, and they had to fire that engine. It had to run for several minutes, and it had to be perfect, or they wouldn't be coming back to Earth. And it did work perfectly, and nobody on Earth knew that it had worked perfectly for a few minutes because they were blocked by the moon from sending back any signals. And when they finally came around the edge of the moon and were on their way back to Earth, and Houston heard radio transmissions from that spacecraft telling them that everything had gone fine, a huge sigh of relief went up. So they blasted with just enough thrust to get out to that point where the Earth's gravity was stronger than the moon's gravity. They only had to get up to about 3,000 miles per hour, so it didn't have to be a really strong push. And then the Earth's gravity captured them, and they were falling towards the Earth. They accelerated faster and faster. By the time they hit the atmosphere, they were going more than 25,000 miles an hour again. So they hit the Earth's atmosphere like a meteor. Heated the outside of the spacecraft to incandescence. It was glowing. Pieces of it were flying off and flying back in their wake. And they couldn't communicate with the ground because the ionization of the gases around the spacecraft were blocking the radio transmissions. They scorched across the skies, they slowed down, the parachutes came out, and they plunked down in the Pacific Ocean, and it was all over. Or was it? You look at this picture and you say, hey, weren't they wearing white suits in the spacecraft? Here's a closer view. Did they get that much lunar dust on them that they turned gray? No, actually, before they were allowed out of the spacecraft, we were still worried that they might bring back some kind of contaminant or pathogen or bacteria from the moon, and there wouldn't be any resistance to it on Earth. And first it would kill the astronauts, and then it would kill everybody on Earth. And we didn't want to take that chance, so they wore biological insulation garments that would keep everything that they brought back from the moon on their bodies until they were safely inside this custom-built Airstream trailer. This was the mobile quarantine facility. As soon as they got off the helicopter on the deck of the ship, they walked into this sealed trailer, and there they stayed for the next 2 weeks. The trailer was designed so that there was always a slight negative pressure inside so that air could maybe leak in, but nothing would leak out. When their ship docked in Hawaii, they moved the mobile quarantine facility onto the dry land, and their wives came and greeted them in Hawaii, but they couldn't shake hands, they couldn't give them a kiss hello, they could only talk to them through the window. What did we get out of all this? Well, we got several hundred pounds of moon rocks and dirt. Is that all? Well, no, actually, we got a lot of information from those rocks. We got some killer pictures. We got really great pictures. You can't get a picture like that from Earth. Did you know that? We got our national pride back. Somewhere in the mid-1960s, we were finally technologically ahead of the Russians in space travel technology. When we landed on the moon, nobody in the world could doubt it. We were there. They weren't. But it wasn't just a moment of pride for the United States, even though it was the stars and stripes that were planted on the lunar surface. This was an achievement of all humankind, and that was reflected in the headlines of all the papers all around the world. They all featured the moon landing, and they didn't say Americans on the moon, they said men on the moon, human beings on the moon. Even the Russians congratulated us. And just to prove the point, the plaque that Neil Armstrong uncovered on the landing leg of the lunar lander doesn't say we came in peace for America. It says we came in peace for all mankind. We got knowledge. We learned more during the space race, from Sputnik to the Apollo moon landings, than we had learned in all the previous centuries combined. That's a lot of new knowledge. We got spin-offs, things that you would never dream, that you are wearing right now. If you shaved this morning, chances are the alloys in your razor blades were Apollo alloys. They were given coatings that are anti-corrosion coatings that were developed for the space program. If you use an electric toothbrush, the things that charge the batteries inside and that keep them from charging too fast and overheating, or that keep them from being overcharged, that was all developed for batteries for spacecraft. If you have a cell phone in your pocket, it's got 2 cameras on it. Those are digital cameras. Before the Viking missions to Mars, there were no digital cameras. Every camera had to have film of some kind in it. All the technology that is inside your cell phone and all your other electronic toys is developed from microprocessors and integrated circuits and circuit chips that were initially developed for the space program. Food preservation and stabilization. In space, they don't have refrigerators on the spacecraft, so things had to be storable at room temperature for days, weeks, maybe months at a time. And they had to be ruggedized so that they could survive the shaking and the G-forces and not separate into molecules. We got baby monitor microphones. There's a lot of noise inside a spacecraft when it lifts off. To be able to hear the astronauts speak and not just hear the rumble of the rocket engines, they had to figure out technology where the microphones would capture the astronaut's voice and filter out all the background noise. That's in your baby monitors right now. The lens technology and the lens coatings in your sunglasses and your prescription glasses, that came from developments in optics for satellites. Some of them were spy satellites, some of them were astronomical telescopes. Better baby bottles. Before the Apollo program, if a mother dropped a baby bottle on the floor, it shattered. It was glass, and then your baby's crawling around on broken glass. Not good. So now baby bottles are made out of polycarbonate, the same material that NASA developed for astronauts' helmets. Speaking of helmets, your bike helmet. I trust that you all do wear helmets when you bicycle. Not only the design and the materials, but the technology of having something that crushes when it undergoes impact and absorbs the forces and spreads them out, that was derived for NASA. Mylar packaging. It keeps your potato chips fresh. It keeps your balloons for get well soon or happy anniversary. Firefighter equipment. Before Apollo, if a firefighter wanted a fireproof suit, it had to be made out of asbestos, which is filled with highly toxic, dangerous fibers. They developed Nomex fabric for the space program, and now firefighters can wear fireproof clothing that isn't toxic. Likewise, the firefighter's breathing apparatus, before the space program, they could carry enough air on their backs to last maybe 15 to 30 minutes inside of a burning building. NASA technology improved that without increasing the weight. Now they can spend up to 7 hours in a burning building. They can get a lot more done in there. Medical monitoring, telemetry, so that if you're in an accident and the ambulance is taking you to the hospital, they can send your vital signs. They can do the diagnosis. The emergency room doctors know what's wrong with you before you get there. They can have the right team, the right materials, the right medicines ready for you when that ambulance rolls through the parking lot. Liquid oxygen technology. If you know of anybody who's got an oxygen concentrator in their house or who uses the boil off of liquid oxygen to breathe, that's thanks to NASA technology. Look around and look at your shoes. I'll bet that at least 3/4 of you, even the ones who dressed up, are wearing some form of athletic shoes. If you're not wearing them today, you know they're in your closet. Trace those back to Neil Armstrong and Buzz Aldrin's moon boots. NASA came up with new materials and new design technologies that are used in all of those athletic shoes today. Shoes that support you, that cushion impacts when you're running, that give you the maneuverability to go in different directions if you're a basketball or tennis player, and the materials that keep your feet warm in the winter and cool in the summer. Cold lasers to burn the clots out of your arteries, and anybody who's using a power tool that has a rechargeable battery can trace it directly back to the lunar core sample drill that Black & Decker put together for the Apollo lunar sampling mission. That includes dustbuster vacuum cleaners and hedge trimmers and skill saws, cordless drills, all that sort of thing. Your water is cleaner because of the technology that NASA put together for use in space stations. If you're wearing a watch that doesn't tick, chances are it's got a quartz tuning fork inside of it. Those were developed as chronometers to use in satellites for accurate timekeeping in satellites. Solar power. Yes, solar panels did exist before we started putting them on spacecraft, but not very efficient and not very inexpensive. They were very difficult to manufacture, and now they're inexpensive enough that you can use them for your little lawn lights. The airbags in your car use fabric that was developed for the parachutes that landed the space probes on Mars. Likewise, the gas generators that inflate them and the impact sensors that tell them when to inflate. Safer tires, the fabric from those same parachutes is in your tires and in your sports bras. We've got cleaner air because of air monitoring technology and the scrubbers that help get contaminants out of the air put out by power plants. You might not think that you use GPS, but you do. Anytime you use Google Maps to tell you how to get to Safeway or Home Depot, they are dependent on 24 satellites that are constantly orbiting and telling you where you are. And all this costs a bucket of money, right? Well, this is a graph of NASA's budget from Sputnik through 2008. And of course it goes way up. It goes above 5% of the national federal budget in the era when they were developing the Apollo spacecraft. But then it drops back to about 1% of the federal budget. Many years it's more like 0.5%. That's about what we spend on potato chips each year. I couldn't find a 1969 federal budget, but this is a 2017 federal budget. I simplified it for you. There's NASA's share and everything else. That's about $1 a piece per day for every man, woman, and child in the United States. $1 a day. That's not that much. As a matter of fact, we spend more than that on soda pop. Coffee drinkers spend many times more than that on coffee. And I have a hard time with this statistic. The average adult in the United States spends almost $450 a year on beer. That's 5 times what we spend on the space program. So we're left with a very simple choice. We can go out and explore the galaxy and colonize other worlds and go out like Spaceman Spiff there on the right, or we can stay at home and give ourselves diabetes. I'd be happy to answer any questions that you might have.